Chapter 12, Liquids, Solids, and Intermolecular Forces. Chapter 11, we talked all about gases, and now we're going to lump liquids and solids together in one chapter. Have you ever wondered how you taste things, and why do some things taste good, and some things taste nasty, and some things are sweet and sour and all that? It's an interaction between molecules in the food, or whatever you're tasting, and receptor cells on your tongue. You have different types of receptors on your tongue, and they interact with different kinds of molecules. So here's a picture of a guy drinking coffee. The interaction between molecules in coffee that taste bitter, which is why I don't like coffee. I wish I did, because the caffeine content is awesome. And it's so socially acceptable, but it tastes nasty to me. So coffee has a bitter taste, which some people really like. But that bitter taste is between certain molecules in the coffee interacting with receptors on your tongue. And that interaction is caused by intermolecular forces. So if we look at this word, we see that chemists are doing it again. We're using, prefixes and things. Inter means between. Intermolecular. So between molecule forces is what these are. They're forces between the molecules. And these types of forces are essential for life to exist. So there are general intermolecular forces that exist between all molecules and atoms, but then there are some that are very, very specific as well. But the fact that we even have any liquids or solids is proof of intermolecular forces. Remember, we talked about gases, and in a gas, the particles are moving independently of each other, and they really don't interact at all. In a liquid, the particles are touchingly close. And the reason they're staying together is not because they like each other or someone told them to, but there are forces of attraction between the molecules, intermolecular forces, and that's what we're going to talk about. So the strength of the intermolecular forces between the particles indicates or determines whether that substance is a solid, a liquid, or a gas at a given temperature. So if it has strong intermolecular forces, those molecules will be strongly attracted to each other, and it will likely be a liquid or a solid. If the interactions are very weak, it will likely be a gas at that temperature. So we need to remember that all atoms are in constant random motion, and that motion increases with increasing temperature. Barefoot people on the sand, right? So just like you guys are moving right now, are you moving a lot? No, but you're not perfectly still. Everyone appears at least to be breathing. Some people have their eyes open and are blinking, right? So we're all moving a little bit. That's the solid state. The particles are vibrating. But as you heat a substance up, the motion becomes greater. Think about Velcro. You got two things that are Velcroed together. How do you get them apart? You pull, right? And you have to pull with a certain amount of force. If there's just a little dot of Velcro sticking two tennis balls together, you don't have to pull very hard. But if it's a big sheet of Velcro, you may have to pull really hard, and you may have to get some momentum and rip on it, right? You've seen those Velcro walls, those bounce house things, and you put on this suit, and you jump and you stick on the wall, right? Never had the chance to try one of those. I think I'd like to. I'm not into bungee jumping or anything, but I think I could handle sticking on a Velcro wall. And yet sometimes your Velcro shoes won't stay fastened. What's the deal with that? Well, when a whole person's body is being held up by Velcro, there's a lot of Velcro involved, right? And when your shoe keeps coming loose, it's this little strip of Velcro, and it's probably got dog hair in it, and so it's just not working very well anymore. Okay, so Velcro is a lot like these intermolecular forces, or maybe I should say the intermolecular forces are like the Velcro. So if the Velcro is strong, the objects are going to stick together. If the Velcro is weak, they're not likely to stick together. So weak intermolecular forces, more likely to be gases. Stronger forces, more likely to be liquids or solids. Another way to think of it is intermolecular forces are stick-togetherness. How sticky are these molecules to each other?